Okay, hello Year 10. Today's lesson is going to be on reflection and refraction. Now, we have a required practical to do on this, but I would like you just to sort of learn the theory behind it. So a few different facts that are really important, and then when we come back we'll do like some tasks to help you consolidate that. So by the end of the lesson, you will have to know the law of reflection, know what refraction is and why it happens, and then do this little quiz thing that I'm going to give you. Hopefully you enjoyed it last time, although only I think 6 people did it, which probably is actually about half the class, to be fair. So let's get started. Right, in here you've got the PowerPoint and the quiz, so let's have a little look then. Now, let's just, there's a question there. Why at night does everything seem louder and it seems like you can hear further than normal? Have a little think about that. Now, there's a few reasons. Everything is quieter at night time, right? Most people are asleep. Less noise. There's less background noise. Less background noise means also less, whatever that sound further away relative to the background noise is louder. Also, because there's less noise, there's less interference, and we talked about interference last lesson. We will see it actually in the classroom, and it'll be a bit less confusing, I suppose. Now, so an object that allows light to pass through is called transparent. Allows some light is translucent, and no light is opaque. Hopefully remember this, probably from, I guess, I did this in primary, but we did it in year 7 too. Now, which two of these show how light rays travel? Well, give you a few seconds to have a think. Now, well, this is a TV. It's got its own light source, okay? So it's creating light, so A would be correct. B, the cup isn't a light, so B is not correct. C is correct. You can see this flower because the sun's rays hit the flower. The sunlight, or I should say the light rays, reflect off the flower and go towards your eye. So that is how you can see this flower here. This is also not correct. The sunlight hits off the person's cap. The light would then go as a straight line into your eye. It doesn't bend. So we can't investigate reflection, so I'm just going to you need to know the rules. And when we go back to school, the people that know the rules will find it a lot easier. Now, this red line here, so let's say you've got a mirror. The hatched bit to the back of the mirror, right? This is just saying that this is a mirror. It's a reflective surface. This red line here is called a normal line. It is at 90 degrees to the surface of the mirror. Now, normal lines are probably the most important part of this topic. You have to be able to draw them and know that they are at 90 degrees. Now, let's just say you've got a light ray coming in. There's my incident ray, because it's coming in. Well, what happens? Let's just draw it going in like this. Okay, and there is the ray coming out. Now hopefully, put some arrows on. The angle here is called the angle of incidence, right? And the angle here is called the angle of reflection. Okay, so incident because the ray is coming in, then the angle of reflection is because it has been reflected. Now hopefully, well, the rule is essentially that the angle of incidence is equal to the angle of reflection if something reflects off a mirror. So what would happen to this one? Well, hopefully you would understand that if it came in like this, it would go out at the same angle from the normal that it came in at. So it would be like that, wouldn't it? So let's, right, now, the language is important here. We need to know incident, we need to know reflected. We need to always measure our angles from the normal line. Now, so when we do this experiment, what you'll find is this angle, say this is 30 degrees, the angle of reflection is 30 degrees, 45 degrees, 45 degrees. You get the idea, it'll be always the same. So the angle of incidence always equals the angle of reflection. Now, this is not reflection here because the light rays have not bounced back. This is called refraction because the light rays have changed direction. So, let's just say you've got air around the outside of a plastic block. When the light ray enters the plastic block, because the plastic block has a higher density than the air, the light ray will slow down. Now I will have some explanations of why this happens when we go back to school, because it's easier to do in a classroom with like models in front of you. But for now, what you need to know is here's my normal line going through the surface of this block, right? So here's my angle of incidence because it's where the light comes in, and here's my angle of refraction because it has refracted out. Now when light rays slow down, they will bend towards the normal. If I drew it straight on without changing direction, you can see that the light ray has bent towards the normal line. So the angle of refraction is less than the angle of incidence. And what happens at the other side is when this light ray leaves the glass block, it will speed up and bend away from the normal. Okay? But if you were to compare this line here to this line here, these two lines, the initial incident line and the line outside the other side, will be parallel because they have ended up back in air, which was the same medium. And again, when you've got practical in front of you, it's a lot easier. So all you need to really know is this green box. So go back to the other slide. We need to know that on reflection, the angle of incidence equals the angle of reflection. And on refraction, when light rays slow down, they bend towards the normal. And when light rays speed up, they bend away from the normal. You need to know that if a light ray enters something more dense than the medium it is currently in, it will slow down. Let's take an example from air to this plastic block. And if it enters a medium that is less dense than the one it is in, it will speed up. So from plastic block to air. Now, it's not just light rays that refract. Water waves also refract when they change speed. And this happens when they travel from deep water, where they travel quickly, to shallow water, where they travel slowly. Now if you look here, the deep water is fast, it has got a longer wavelength. The shallow water, it moves slowly and it has got a shorter wavelength. So the wavelength gets shorter and it changes direction. Now if you drew a normal line across here, right, you would find that the blue line is at a larger angle than the red line because the wave has bent towards the normal. So what kind of surfaces make the best reflectors? Well, we should know smooth ones. So this top left one is toilet paper. This is a wood flooring. Here you've got a shiny work surface, and here you've got a glass. So you can see toilet paper isn't a very good reflector because look how rough that surface is. That wood flooring's alright actually because you can see it's quite flat. The same for here. What you're looking through that top layer into where the stone bits are, and you can see it's quite shiny. And here this is very, very smooth, right? And the glass is good reflecting. So let's compare two things. Mirror versus paper, right? Smooth surfaces reflect stuff uniformly, and rough surfaces scatter stuff. So it could be sound, it could be light, okay, in all directions. So if you look there, they all come in uniform and they all bounce off nicely. Whereas this one, paper, you can see, if I get my pen again, right, this one comes in and they all come out nice at the same angle. We call that specular reflection. This one, they all come in at the same angle, but they leave at a different angle. We call this diffuse scattering. So that is why you can see your reflection in a mirror, because it's nice and smooth. And that is why you can't see your reflection in a paper, because it's rough. Now, that is really all you need to know for today. I just want you to know some of the facts, and then I want you to have a go at this quiz here. Okay? Please use some sort of name that I can recognize so I can mark that you've done it. And that will be what I will use to mark your attendance for the lesson. So please use a name that I can recognize.